Now I am talking about the connection of different appliances in our household circuit. In our household circuit we are using different type of appliances. Some are lighting appliances like tube light, bulb, etc. Some are heating devices like electric iron, electric heater, rice cooker, etc. And some of them are different. Just for example, refrigerator and another appliance. Other appliances are also used, just for example, water pump, etc. etc. All these appliances which we connect in a household circuit are connected in parallel with each other. I am going to show you a simple representation of parallel combination of these appliances. Look at this. This light line and neutral line, two lines are supplied to our household circuit which are connected with different appliances. I am taking few of them. This is a bulb which is connected in parallel with this. Let's say this is a tube light, and this is connected in parallel with this another one. Let's say this is electric iron. Bulb, tube light, electric iron. All of them are connected in parallel with each other, and this is the parallel combination. And there are some advantages of parallel combination. I am going to tell you the advantage. One of the main advantages of this combination is voltage does not divide among the appliances. 220 volt is the supply voltage in household circuit, and this voltage will be taken up by bulb also, tube light also, this electric iron also. All of them get same full supply voltage, 220 volt, and they are designed in such a way that they runs with the same voltage. I mean to say, they are designed to run with 220 volt. That's why one of the major advantage of this combination, parallel combination of appliances, is all the appliances gets full supplied voltage. If it was not so, if bulbs were connected in series instead of parallel, then 220 volt divides among them. It becomes 110 for two bulbs, and if 4 bulbs are used, each of them will get just 55 volt. This way, if voltage drops down, then the brightness of the bulb will be less. They will give us dim light, and that wouldn't be possible to see the object clearly in the rooms. That's why one of the major advantages is all of them are getting full supply voltage. Now next, because of this parallel connection, individual switches can be used with each of them. Just for example, here, if I want to use this bulb now, then I put the switch on. But I don't want to switch on the tube light, then I put the switch off. If I want heater at this time, I want to get heat energy from heater, then I put the switch off. This way, what I want, according to that, I can use each and every appliance individually. If I want all of them, I will switch on all of them. If I don't want anything, I am going out, then all of them can be switched off. According to the requirement, I can use them individually. That's why this is another major advantage. Individual switches can be used with each of the appliances to use them separately. If they were connected in series like this, bulb, tube light, heater, if they were connected in this way in series, then what happens? If switch is placed in the circuit, whether I am taking switch at this place or at any other place, if switch is on, all of them works. If switch is off, all of them doesn't work. That's why this is one of the great advantages of parallel combination, that individual switches can be used with each of the appliances to use them separately. Now let's talk about another advantage. The bulb requires less current to run, but a heater requires more current. Now let's take example, power equal to current into voltage. All of them are getting the same voltage, 220 volt. And power of the bulb, let's say it is a 100 watt, then how much current it requires can be calculated easily. I equal to 100 watt divided by 220 volt. If we divide, then we'll get this result 0.45 ampere. It means this much current is pulled by this bulb to run. But if we calculate the same, how much current is required by this heater, the same, P equal to I into V, then voltage is same because in parallel combination it doesn't divide. Now I am going to calculate current. Power of this heater is not 100 watt. Normally heater is of 1000 watt. And now if current is calculated, then 1000 watt divided by 220 volt. This is equal to 11 4s are 4.5 something ampere. Okay, more than this. Okay, 4.5 ampere current is needed by 1000 watt heater. It means some of the appliances of our household circuit requires more current to run, some of the appliances requires less current to run. And if current is very high than that of 0.45 ampere for bulb, then its filament will break. That's why, to control the current, to allow the required amount of current, we can use fuse in this circuit. And if current exceeds the limit, the fuse will melt and it saves the appliance whatever in its circuit, in this circuit. In the same way, we can use another fuse here, which is designed in such a way, which is placed in such a way that it allows this much amount of current, 4.5 ampere, but not a lot, like 15 ampere. So, fuse is of different capacity, and fuse is used in electric circuit for the safety of that appliance. And if here current is needed 0.45 ampere only, we can use fuse of 0.5 ampere or 0.6 or 1 ampere only. But if current exceeds 1 ampere, 2, 3, 4, 5, then this bulb will be damaged. And in the same way, this heater requires more current, 4.5 ampere. That's why if we put 1 ampere fuse, then it will melt when we switch on the circuit. So we have to put here high capacity of fuse, maybe 5 ampere. We can use here 1 ampere only. Here we can use 5 ampere. This is possible. Possible means individual fuse can be used with each of the appliance according to the requirement. This bulb pulls less amount of current, so I want to put a fuse of less capacity to run it. And if current exceeds the limit, then to prevent the damage in this circuit and damage on the appliance, I put the fuse. And fuse should be of a little more than the required current. Required current is 0.45 ampere. We can use 0.5, 1 ampere fuse here. In the same way, here, the required current is 4.5 amperes. That's why we need to put a high capacity fuse here. This individual fuse can be used with each of the appliances to run them separately, and that's why this is one of the another important characteristic advantage of this combination. Individual fuse can be used with each of them according to the requirement.